just to get the nerves out, I'll say this is staggering. The level of expertise in this room is overwhelming. Thank you. This being here in Iceland to talk about some of these gaps is sort of the birthplace of where some of the gaps, the aha moments, are even originated. So I hope that you give us a bit of patience if we don't know all of the opportunities and learnings that have happened, but it is because of the hard work that has happened from many of the people in this room today that we've even been able to compile this set of work. So I'm going to start with just a bit, well, most importantly, we will have coffee again, so please do go find it. And when you do find it, there is a poster that we created capturing some of the highest priority gaps. It's near the back of the room, so please take your time. You might need a set of reading glasses. There are a lot of them. And then we'll also have lunch. You can see that's going to happen in between the second and third session. Also, I wanted you to take just a moment to see how we have categorized these technical verticals so that you can see where inherently we might actually have created new gaps by siloing the expertise. And we're keen to take in your feedback on if we did miss something in a category. So here you'll first hear from drilling, so what is happening in the world, and more importantly, what can't we do well at reduced risk in each one of these categories. So starting with drilling, then moving into well construction and design, then power production, sort of the surface equipment. I'm sorry, I skipped right over heat extraction. So this is both talking about the EGS and ever so slightly some closed loop system solutions. And then dropping right down to the very last one, siting and characterization. That one is unique in that it is the last in the series and also still in its scoping phase. So a representative from Cornell University will be here to talk through how he is picturing scoping this work and taking in your feedback. So quickly on Clean Air Task Force, who we are, why we're here. So first, Clean Air Task Force, 25 years on 5 continents. Our mission is to push technology and policy toward a zero-emission, affordable energy world. That is all of our work, and the way that we hire is first identifying technical expertise as well as policy experience to be able to press forward these technological solutions that we believe can basically mitigate the worst effects of climate change. However, to be in Clean Air Task Force, we have 8 programs. To be invited into we'll call it the inner circle of Clean Air Task Force, you have to be all 3 of these things. You have to be nascent, you have to be transformative, and you have to be tractable. And in this case, nascency is really obvious. We don't have a solar program. We don't have an offshore wind program. These are not technologies that need my shoe leather. They have plenty of it out there. Now, but to get to the next one, to be transformative, this is where we're defining transformative with 2 key ingredients. It has to be deployable, meaning it needs to be a solution that is possible across the breadth of the planet in order to have true impact and opportunity. And in order for it to be adopted in many areas of the globe that are actually experiencing the most energy growth, it needs to be cost competitive. So without it being cost competitive, it won't be adopted and is therefore not a true transformative solution. And so you'll see off to the right that we have been working with the University of Twente in the Netherlands to come up with a new way of estimating where we can access 450 degrees and higher. 450, there's nothing special about that. We just added a few extra degrees on in order to ensure that the potential highly saline waters are hitting the highest enthalpy content possible. When we did this work, what we found is that after we estimated the entire potential, and then we removed 99% of that potential, we are still estimating over 63 terawatts of potential, 8 times our current need. Now, getting to the cost competitive, We estimate, given modeling and sort of an LCOE approach, that we will see prices as low as or competitive with the lowest cost suppliers today. And this is, in order to put on our realistic glasses, I need to also point out the right side of that, or I'm sorry, in this case, yes, the right side. We won't start there. It will be expensive in the first, but we expect the price to come down quickly, and I'll talk briefly about why we have those high expectations. The rest of this session is really going to talk about that tractable. Why do we believe it's really possible? And that is how we've invited some of the most brilliant people that we have worked with and know well to think hard about where these gaps are and what we need to do to make a pilot in the Superhot realm possible. Now, I suspect that there are many reasons that each of you showed up today. Why Superhot? What is it that moves the needle for you? And it could be curiosity. It could be, for those that follow Vaclav's Mills hypothesis, we're all going to end up going toward that most energy-dense opportunity and resource possible. But the reason why we're here is we think it's going to be the lowest cost solution ultimately as well. And to give you a sense of why we think that, why Superhot Rock is perfectly poised to be one of the lowest cost providers of clean, firm power, we break it out into these categories. First, by going with the high energy density resource, we are enabling higher capacity plants. So this is not the 50 megawatt plant stamped and approved everywhere. This is 250. This is potentially 500 megawatt plants. By getting there, we're reducing the balance of the balance of plant costs, and therein reducing the overall cost of the per electron. Needless to say, we also see a smaller footprint and fewer wells, which will ultimately affect the bottom line of CapEx. And then finally, by targeting these ultra high temperatures and high enthalpy systems, we expect increased efficiency in the actual surface production. So now we no longer need to accept a 15% efficient turbine. We can now start to see efficiencies that is common within the gas and coal industry by increasing the enthalpy. The other reason that we anticipate the cost or pressure on the cost throughout the arc of this technology is, first, we're going to completely remove the risk of dry hole. In fact, that is where you are going and intentionally going. And while I don't want to dismiss the complications that create the flow in the subsurface, they are difficult, we no longer will have the dry hole risk that drives up the cost of capital due to the risk seen in missing your resource. And then in addition to this bottom line, you could put solar in this particular row. It is the effect of driving up demand, increasing its global footprint, supply responding, and the cost going down. This is exactly what we saw in solar cells, as well as what we're seeing in batteries, etc. Finally, why now? Why are we having this conversation today? And the opportunity that we see is a combination of observing what oil and gas has been doing, specifically the shale gas revolution and the cost reduction that we have seen there. You can see in the chart off to the left here, the cost reduction over a 7-year period was 150% of its original cost. We expect something very similar in the overall cost of the subsurface within the Superhot spectrum once we are dedicated to that at scale. And then the second ingredient is, again, the hard work that a lot of the people in this room have already been doing. The IDDP 1 and 2 stories, the potential for 3. Also, many other projects. We have documented well over 40 wells in the world that have already reached 400 degrees. This is possible. This is tractable. This is not a breakthrough. It is just engineering iteration with intention, and ultimately getting us to a cost point that is competitive with all of the other options. As you can see, we've placed Superhot on the Lazard chart. We definitely dropped it in there. Don't ask Lazard about that. So with no further ado, I want to introduce the authors from the drilling report. We have Tony Pink from Pink Granite Consulting, and Rebecca Pierce from Cascade Institute. This duo spent countless hours interviewing various technology providers in the drilling spectrum, really getting a sense for what are they doing, but perhaps even more importantly, what can't they do yet. And so I'd like to introduce Tony and Rebecca. That's you.